Hello everyone, I'm Okari and welcome to another one of my tutorials. This time around we are going to take a look at the dynamic crosshairs that I recently did a speed prototyping for actually. And we're going to extend it a little bit afterwards, but I'm going to go over it now in some more detail, kind of covering the concepts and how it's all put together. Here I am in an initial just fresh first-person game mode. And if I hit play here, we can see that by default, I already have these little crosshairs. So we want to get rid of those real quick. That's found over in the first-person game mode, over in the HUD class. We're just going to turn that to none for now because we're going to be making our own. And the other thing I want to do for setup purposes is give myself some kind of button to aim with. So since most first-person shooters use the right mouse button for aiming, let's go ahead and do that. Let's go ahead and go over to project settings and go over to our inputs, and we will add in a new action mapping. I'll call this aim, and I will tie this into the right mouse button. And that kind of handles our prep for this project. So there's going to be a couple places we're going to be working with. We're going to be working inside the first person character. We're going to be making ourselves a widget, and we'll be making ourselves a blueprint interface just for consistency's sake. So let's go ahead and start with the actual widget that we're working with and experiment with that first. I'll go ahead and create a new one, widget blueprint. I'll go ahead and call this dynamic crosshair widget. And now that I'm in here, I'm going to go right over to the graph. There's not going to be anything that we add to here. I've seen a lot of tutorials that try to do this with different images, like they might do like a slideshow or a flip show, basically, a flip book of different images, or like they'll split the crosshairs up into different sections and you'll move the images around on screen. We're going to ignore that because I think this is a cleaner and better way to do it. We'll be overriding the OnPaint function over here. And if you have never used this beforehand, I have another tutorial that kind of covers the concepts of what OnPaint is and how you can kind of use it, because it's extremely powerful because it's drawn every single frame. And the major contender for what we'll be using in here is we're going to use a draw line node. And just to give you an example then, if I draw a line here, if I'll just plug this in, make sure I add the proper context, and we'll make our first position 0, 0. The next one we'll make like 300, 300. And if I just go ahead and compile this, and we have to make sure we add it to the screen first, so let's go ahead and actually just go over here to the first person blueprint. We're just going to override this event begin play because we don't care about any VR stuff. We're going to create widget, set it to our dynamic crosshair widget. For later purposes, we'll promote this to a variable. We'll call this Dino Crosshairs Ref, and we'll make sure we add it to the viewport. Get rid of that. Okay. And now, if I go ahead and hit play, you'll see that we have a super awesome little fancy line there in the upper left-hand side. And this is the basic concept we're going to go with this entire time. We're just going to add basically 3 more lines and reposition them more on the center of the screen. So how do we find that center? Well, we'll go ahead and use our get viewport size. And we're just going to divide that by 2. Now if I go ahead and plug that into our second position, we will see that we have a line then that is kind of not quite there. You'll see it's kind of strange, isn't it? Especially with what's going on here. That's because we've got some weird issues going on with scaling. So the other thing we need to do here is actually take our viewport size, divide by another vector 2, and for that we'll plug in get viewport scale. Oops, wrong one. Let me grab the divide by float. Plug that into our division of 2. Go ahead, hit play. And then now, because we fixed for scaling purposes, you will see that regardless of the size of my screen, I will always get the center of my screen. So this is very, very handy now. So what I'll do here is I'm not going to worry about right now for optimization purposes calculating this and saving it in a variable somewhere. We'll just leave this here as it is, and you can always optimize things later. So this is going to find screen center, and so there's that. Now I do know one thing I want to do here is, now that I have my screen center, what I could always do here is I could add another vector 2, and just for reference then, I'm going to make this a variable, and I'm going to call this center shift. And what this would end up doing then is, if for example you're, let me plug this back in, you're actually playing a shooter or something, and you don't want the exact center of your screen to be where your crosshairs are. Maybe you want it a little bit lower, or you want a game where as you're moving forward or something, you see it bobbing around back and forth. This is how you could kind of shift that around. We're basing it all kind of off of a point that we've picked in the center of the screen, but we can shift that around however we want. The next thing I want to do then is I actually want to shift around where I start drawing my line. So we only have one line being drawn right now. We need 4 lines to be drawn. So I'm going to go ahead and copy this 3 more times. And we're going to label them so that we can keep everything organized. So we're going to call this one up. We're going to call this one right. And if you're following, you're probably going to notice that we're kind of going around this thing clockwise. So this one will be called down, and then our final draw line will be called left. And so this is where they're all going to be drawn from. Just plug those contacts in, and we'll add ourselves in a sequence so that we can keep this a little bit cleaner visually. And I'll add in a 4th specifically because for the OnPaint you do need to have this return node, but I just want to return this at the very end, so that's just going to sit right there for after we're done with all of these actual draw lines. Then we can tell the Unreal Engine that we are done drawing through in OnPaint. So the next part is I have a point in my center. If you understand vectors and such, what we're going to do here is we're just going to kind of shift our center position based on a direction. So I'm going to create myself, create vector 2D, make vector 2D, and I am going to set myself up with 4 different vectors. So I'll go ahead and copy this 4 times. And we will do the same kind of little labeling thing here so that we know which direction each of these are going to go. So up, right, down, and left. And so for up, we want it to go in the positive y direction, so 0, 1. For right, we're going to make this positive x direction, so 1, 0. And these are all unit vectors so that we can do easy multiplication and math on them. So down would then be negative y, so negative 1, and then left would be negative 1 in the x direction. So now I can take all of these and I can add myself in a variable here. We'll make it a float. And then we'll call this distance from center. And I will just compile this so we can get an initial number. We'll call this 30. Just for now. And what we can do here is we can get this distance from center, and then we can multiply it out to give these all some kind of magnitude out. So what I'll do here is take this, multiply that by a float, and once again I'm going to copy this a couple times, wire these guys up, just kind of align them a little bit better. And then just move this kind of up and out of the way there. So now we have our position A. What we want is our position A to be kind of modified by these. So we want that center point, but we want that center point shifted based on each of these. So for our first one here as an example, I'm just going to add that there and then plug that into position A instead of the center. So what I've done now is I've taken the center, I've created a vector with magnitude, and I've added it to shift that position somewhere else. Then I can do the same thing with the others. Just going to add in a little bit there. And this is already starting to be a little bit messy looking, so we're just going to shift some things around here. And I'll probably convert some of these guys to some macros at some point. All right, copy that 3 more times. And pull off here to add in the center position to each of them. Now each one of these is shifted in a different direction, and so we have our center. And what I can do here, oops, wrong one. What I can do here then is, after I've plugged all of these in, rid of those, I can then just simply plug in, for example, we'll just actually leave these as 0, 0 for now. We'll just compile this and see where they start out at. So now you can kind of see I've got these 4 starting positions around the center, as it were. And right now they're all aiming towards 0, 0, 0 on my screen. So what I'll do then for my secondary position is I will take this again, because I still have this as a distance, or sorry, direction. Shift these down a little bit. I'm going to copy this. I don't actually want the distance, but I do want all of my vector 2's plugged in again. And what I'll do here is I will multiply them by a different value float. So this will be length of crosshairs. And we'll call that, it's 30, we'll make that 40, make it a little bit longer. I will drag out a get reference. We'll plug those in. And now what I can do is, since I have a different vector length, still going in the same directions then, what I can do is I can actually take the return value from here, and I can just add my new vector value here. And this will give me another position just further out in the same direction as the previous crosshair. Now the difference here is I don't actually want to drag it out from the same pin here. I want to do each one of these separately because they each now have their own separate location on screen. And then I can plug all of these into the B position for all of these draw lines. I'll drag that out just a little bit more so it's becoming a little bit less hectic looking. Compile that, and now if we hit play, we can see that we have our crosshairs now drawn on screen. And so if I were to, for example, just for the heck of it, because it's always fun, we can, for distance from center, what I'll do here is I will make a pin of this one, and we will plug all of them into there. Instead of doing from distance from center, what I will give it is a random float in range. And we'll go from like 0 to 30 at this point. And this will kind of simulate at least some variability in our position. And so now you can see that all these crosshairs are kind of moving around. So we've got that kind of, we have that motion that we can now build around. So I'll go ahead and plug that back into distance from center. And what we will do here then is we will add in another value that we're going to create. So this value is going to be called our accuracy modifier. I think I misspelled that. compile that, and that's going to be 0 for now, and in the event graph we'll end up changing that. But in here what we will do is we will tell it that this distance from center is going to be the distance from center plus our accuracy modifier. And then that's basically all we really need to do on this end. We have everything set up. Now we just have to kind of create the instructions and everything. So our next step then is going to be creating our blueprint interface to work with our widget and our first-person character. So let's go ahead and add in a new interface. I'm going to call this dynamic crosshair interface. And it's going to have two different functions. We're going to call this one aim accuracy adjust. It's going to return a float. We'll go ahead and make sure we call that aim ACC for accuracy modifier. And then we're going to also add in a movement accuracy adjust. And it too is going to return a float, and we're going to call that one movement ACC modifier. Alright, that does it then for our interface. Fairly simple there. I'm going to go back to my widget here, and I'm going to actually change this from a single modifier, a single variable that'll store our modifiers to 2. So we're going to rename that aim accuracy modifier, and we're going to add a new one in, and we're going to call it movement accuracy modifier. Make sure that's a float. Drag that in. Add a new pin to our add node, and add that there. And that'll take care of that little correction. And then to add in our blueprint interface, we'll go ahead and go over to our class settings. Make sure that we add in our dynamic crosshair interface. Go ahead and compile so we can get our events. And then we can pretty much just go up here to our add events, and then our custom ones, aim accuracy adjust, and then movement accuracy adjust. And all these will do is these will, whenever they're called, update the values currently stored there. And now that it's plugged into our actual widget, we can now make the controls on the player's end that kind of modify and change this. So we're going to go ahead and go over then to our first-person character and continue from here. Okay, so in our first-person character, let's get the simple one out of the way so we can kind of see how this process will be built upon. We're going to go ahead and add in our aim. So I'm going to go ahead and grab my aim action event. And so whenever this is pressed or released, I want to either zoom in for my aiming or reduce my aiming or accuracy quality. So what I'll do here is I'll add in a timeline. We're going to call this aim timeline, or aim accuracy timeline. And when we go in here, we're going to make sure that we have a float. This is going to be our aim delta. And we're going to start this off at like 0.75 seconds for our length. We're probably going to shorten that, but for now that's fine. I'll add a keyframe at time 0. And I want my value at 0 to be 0. And I'm going to add in a keyframe then for my last one. So we're going to put that as 0.75 for now. And we're going to make that a value of 1. Compile that and jump back to our event graph. Now, every time that we call this, we are going to update that value that we have stored in our crosshairs. So I'll go ahead and get a reference to our widget. And we're going to go ahead and send it a message. We're going to tell it that we have an aim accuracy adjust message. And we will call that on the update. And we don't want to send it the delta on its own because we want to modify that delta by whatever it is that our maximum potential aim is. So I'm going to give myself a new variable here that I can store on the player's end. I'm going to call this max aim adjust. And this is one of those situations where if you have different weapons, this would be the easy way, or this would be the place then to kind of change it based on weapon type, where you'd how accurate you want to get. Like sniper rifles potentially be more accurate. You know, shotguns can only get so accurate. So you know, you could make changes for like what those particular weapons have for a max aim adjust. So for its max aim adjust, I'm not going to do 30 because I don't want to continue the vector direction in the crosshairs. Remember, if we look here, we're adding this from our distance from center. So I'm actually going to tell it that I want to make this a negative number. So I'll probably make this like negative 20 for now. And then I can multiply those values out. And now I'll get a range anywhere from 0 to negative 20 that I can go tell it, this is your current aim accuracy modifier. And then when I release the key then, so right now I only have it starting to be at play. If I release the key, I just want it to reverse from wherever it is. So I'll go ahead and hit compile, and we'll just test this out real quick. All right, so now there we go. I just hit the right mouse button, and we can see that we are now aiming or not aiming. And wherever we are, if we release, we will lose that accuracy and such, or gain it if you click it again. And again, that does feel a little bit slow, so I'll probably change that to like 0.4 seconds, and we're just going to make sure that that is also at 0.4. And that feels a little bit better. So there's our code then for aiming. Really straightforward, but you can kind of see the concept we're going with the timeline. I'll go ahead and just put a comment box around that. So we've moved over to our movement input section of the code right up here. And there are already two events that we can kind of begin using to run this. These events will run basically every single tick. If I just drag out a print statement here, we can kind of see that every single tick that we're playing, we will get this value that basically covers, for this one, moving forward and backwards. And then the other event will end up working with the left and the right. So since these already actually work every single tick, we are going to use these to kind of drive our movement, because we need to know, and at any given point in time, have we stopped moving or have we started moving? So what we're going to do here is we're going to just add ourselves a little code here initially to kind of keep track and record this value. So I'm going to add myself in here a new variable. This is going to be a float. And we're going to call this one current movement delta. And what we're going to do here is we're going to set this, and every single time one of these is running, we are going to go ahead and simply get the max of it. All right, so I'm going to drag out from my axis value up here. We're going to get the absolute value of it because we only care about if it is moving or not if it's moving one direction or the other. We're going to grab both of those from our move forward and our move right, and we're going to take the max of that. So we know that this is going to basically range now from 0 to 1. And we're going to store that value. And what I'm going to do is I'm going to actually take this, just for cleanliness sake, and I'm going to collapse it into a macro. And this is going to be record current movement delta. We'll change that to execute. So this one will be our forward delta. And the bottom one will be our lateral delta. We'll go ahead and make sure that this has a execution pin on the outside of it. I'm going to hop in here just to make sure that that actually connects. And there we go. Now we're actually recording this and we can use it elsewhere. So the next thing I want to do is I want to double check to see if we're actually moving or not. So what I will do is we'll go off of a branch. And for this branch, we're going to grab our current movement delta, and we're going to see if this is greater than 0. If it is, we know that we're actually moving. And if we are, what we want to do, the second we start moving, we want to ruin our accuracy. And then if we're not moving, we want to recover it. So I'm going to go ahead and add ourselves in here a do once, because I only want to do this once when I know that I'm getting ready to actually start moving. This way I'm not constantly resetting stuff. So the idea here is that the second we start moving, we're going to do something, and this something is going to occur, and then once we stop moving, we want something else to occur. But we only want to mess up our accuracy once we've begun to move. All right, so what we'll do here is, just for reference, we're going to grab our dynamic crosshair reference, and we're going to go ahead and send it a message. Movement accuracy adjust. And we'll take our movement, our current movement delta, and we will need another accuracy adjust, kind of just like we had with the max aim adjust. We're going to add ourselves another variable for max movement adjust. And this value is going to be positive. The reason this one's positive is because when we start moving, we want to increase the distance we have for our crosshairs from the center. So we need a positive value here. So I'm going to choose 30, for example. So what we'll do here is we'll take our max movement adjust. We'll multiply these two together. And we'll send that information to our widget. Just to verify and check this, then I can go ahead and hit play. And then once I actually start moving, nope. Okay, where is this error? Oh, here we go. We don't want less than 0, we want greater than 0. There we go. So now once I started moving, it will set my accuracy to much worse, and there we go. So now the idea is we want to then recover this. So this is only going to trigger once. So we could branch off of this so that once this is false, we do something else. So we can try that first. Yep. So what we'll do here is we're going to add in a sequence to each one of these. This is going to be a little bit strange. So I'm going to add in a custom event actually first. This is going to be, oops, reset movement do once. And I'll add another do once. This will be from when we stop moving. And we'll add in another custom event here. This will be reset recovery, or accuracy recovery. Do once. And the idea is we'll give ourselves a sequence for each one of these, and then after that sequence is done, we will unlock the other one. So this one will then go ahead and unlock the reset accuracy recovery do once, and then we'll give this one a sequence, and then the second thing it will do is call reset movement do once. So we just drag those down. Okay. And so the idea here then is for recovery, for now let's just real quick, just as an example then, go ahead and copy these. run that, and we'll just leave it at that default 0. So there we're moving, we're not moving, we're moving, we're not moving. So there we go. So now the idea then is we want to actually add something a little bit more dynamic and timeline-wise so that when we stop moving, it doesn't go immediately from inaccurate to accurate. It's going to take a moment or two to get there. So what we'll do is we'll have it run a timeline here. This is going to be movement, accuracy, recovery. And we always want to play this from the start because we know that we're going to start from whatever our current value is and run down from it. So let's give it about 1 second. We'll see how that ends up feeling later. This will be accuracy or move accuracy delta. We'll start this one at time 0 and a value of 1, our worst, because we know that's currently our worst or our maximum. And at the end of it, we want to go to time 1, and we want a value of 0. And I'll go ahead and plug that movement accuracy into a multiplier. We will go ahead and grab our max movement adjust again. That way, as it decreases, we're kind of decreasing that as well. All right, let's give this a shot and see how it looks. There we go. Stop moving. Accurate again. Moving. No longer moving. What if we start moving again in the middle, though? All right, so we do have a quick thing we need to fix then. Basically, need to tell the timeline that it needs to stop moving. So what we'll do here is we'll add in another pin. For cleanliness, I'm going to add in another custom. Rather than just plugging this in down at the bottom here, I kind of prefer to keep things with custom events. So stop, move, accuracy, recovery. So what we'll do is we'll stop that. And so what I'll do here is I'm going to move these down. And so if it is running, this is just a kind of general test of, or check basically for, we're just going to stop this if it is running. If it's not running, nothing will happen. If it is running, it will stop because we know that we want to then override this and keep it inaccurate again. There we go. There we go. So now we can start moving again and it will reset itself. And if you're carefully watching, you'll notice one thing we need to check. You'll notice that we go from inaccurate to accurate right off the bat there. So that might not be something that matters to you, but just to kind of fix that, what we can do is we can start with this one closed, because when the game starts, we have a value of 0, and since this do once is open, it will run real quick and trigger, and it will run through this movement accuracy recovery real quick, and that's what's causing it to become inaccurate and then go accurate again really quickly, or right there initially. So just by starting this as closed, we're basically telling it, look, we're going to wait for this one to ever trigger, and we're going to run through this, and we're going to wait for the sequence to actually open up this do once for use again. So now it won't pop anymore. So now I can keep moving, I can aim, and our aim is kind of, right now, if I'm aiming, all we're getting is that little like change in our crosshairs. Let's add in one more thing before we keep going. Let's go back to our aim controls and add in a camera adjust. So what we're going to do here is we're going to add in a reference to our camera. So I'm going to grab my first person camera here. And we're going to set field of view. And if we look at our camera, we can see that our default is a view of 90. So let's go ahead and grab that. I'm going to make sure I grab that, and this is going to be default field of view. Compile, set that to 90. I'm going to drag off this delta then and multiply it by another float. and this will be our new kind of adjustment for our current field of view. I need some kind of other variable to keep track of how much we want to subtract. So this is going to be max camera field of view adjust. I'll leave that as 30. Drag that in and add that. And then I'm going to subtract float minus float, because I know I want to make this slightly more inaccurate. And I will subtract then, here's our default field of view. And I can plug this in. And when we run this, go ahead and compile. Now when I aim, I will get that kind of really nice little zoom effect, while I'm also, zooming in the crosshairs themselves, which is really nice, if you want to make something more visually accurate and easier to hit for the player as well. Now that we've gotten the crosshairs working as we expected them to, we're going to do one final thing in this tutorial, and that's going to be actually giving us a way to randomize the fire that we produce so that it stays inside of the crosshair inner region. So to do this, we're going to go ahead and go back to our first-person character, and we're going to override right after our montage play. And this is where we're going to produce a line trace then that we're going to cast outward and find a point somewhere inside of those crosshairs. So go ahead and add a line trace by channel, and this is going to be what is going to produce all of our firing. So let's make sure that we draw this for like a short duration. Let's say, for example, 0.5 seconds. Now to find the region we want to fire in, we're going to use a node called deproject to screen, from screen. So deproject screen to world. This transforms a given 2D screen space coordinate into the 3D world space position and direction. When it means direction, or when it says direction, what we're talking about is kind of, if you think of every single pixel that you have here, the camera exists in one place and then has that forward firing direction that it traces through the world and then decides what did I hit and what should this pixel be. And so that's what we're going to use to draw all of our shots from. To get this, though, we need to get a player reference. So we're going to go say get player controller. We're going to make sure we use that. Oops. And it's asking also for our screen position. So we need to get the center of the screen to start with, and then we're going to do that same kind of aim accuracy, kind of adjust stuff as we did with the drawn crosshairs. We're going to do the same kind of logic here with these particular values. I'll go ahead and get viewport size. And we're going to test this with doing a single ray that we're not going to end up adjusting at all. So I'll go ahead and divide this by 2. Go ahead and plug that in. You may remember from our dynamic crosshair widget, if we go back to our graph here, this is the logic we use to find the center of the screen. We take the viewport size, divide by the scale, then divide by 2, and that gives us the center. You'll notice that I'm not actually dividing by the scale here. And this is something strange that we're going to see that I really don't have a good explanation for why this is the case. If somebody wants to add to the comments if they know why this is the case. But adding in the scaling will actually kind of mess up our location. So I'll go ahead and start our line trace from our position. And then I'm going to take this and add to it another vector. And that vector is going to be the unit vector of direction that I have multiplied out with a value to give it some kind of magnitude and just send it off in a direction. And that will be the end. So if I compile this now and hit play, if we pull that trigger, you will see that every single time we are hitting the exact center now. And like I said, if we add in that same logic here of dividing by the viewport scale first, just so we can see what happens, we're going to see something very, very strange. We're going to see that our shots begin kind of firing off in a slightly different direction. And you can kind of see that there. So for whatever reason, this is not necessary, or this is not desired on the blueprint end of this kind of logic. So now that we have our generic center shot, we can then modify the adjustments and such based on how we'd like it to kind of be accurate, more accurate or inaccurate. So I'm going to create a macro for this, to be honest, because I'm going to keep this completely self-contained. And we're just going to be outputting a vector 2D. And we're going to call this aim, or this is going to be the firing accuracy adjust. And inside of this macro, which I should actually call firing accuracy randomization, we're gonna end up working in here, and we're gonna make everything kind of randomized based on the values we have. And so in here, we're gonna go ahead and grab our current aim adjust, which if we look at the event graph, we are storing each time. And then we should have a current movement adjust that we're storing each time as well. So we can go ahead and grab that. Current movement adjust. And what we'll do here is we will go ahead and give ourselves a random float in range. And we're going to need 2 of these, because if we only use one, we'll end up seeing that actually. We'll do one first. We're going to get a diagonal effect where we call this at the same time. It's going to return the same value from the return value. It's not going to produce multiple return values if we try to use it twice. And what I mean by that is if I go ahead and split this pin and I were to plug this into both of these values to kind of give us a X and a Y adjustment, it's going to produce one value in the float and then send that to both the X and the Y instead of giving us a randomized 2 different values. And so the minimum we want is going to be a negative number because we want to go one direction, and the positive will be the positive value of the combined maximum we have here. So what we'll do here is we will add them together. We can plug that into our max. And then we're going to multiply this by a -1. We'll plug that into our minimum. We're going to come back here to fix that error, and there's another error we're going to see here, but I want to show you guys this first. So we actually need to plug that macro in. So add a vector plus vector. Go ahead and grab our firing accuracy randomization. And it's not going to be moving at all. Our error is we needed to add one more value here because right now these are potentially both 0. We need to add in a value that is going to consist with our set distance from center that we have by default. So I'll hard code that for 30 at the moment. And you're going to see something strange. So first off, there's our error with the float in range that I was talking about, that randomization. It's always going to occur in that kind of a line there. So fixing that first, what we'll do is we'll copy this. Just plug these same values in. And then we'll just plug one of those into the other output. So we have one of them dedicated to the adjust X, one dedicated to the adjust Y. Compiled and running again, you'll see now that we have a much better randomization. You'll also note that we are definitely going beyond our crosshairs. Like if I aim, even then we're kind of going beyond that. And the issue for this is we need to divide our value in half before we do anything with it. So go ahead and move that over. And now we will end up being inside of those crosshairs every single time. If I zoom in and aim, it's going to be a little bit tighter, but there we go. And if I move around, I'll go back and forth. It's a little bit easier to see. We are maintaining inside the larger region. And that itself is the setup then for if you want to create or generate a randomized position for a line trace and such. Hopefully you guys find this tutorial interesting and useful. Good luck with your own implementations. Thank you very much for watching.